For our project, we made an LED spinner that rapidly alternates the values of the LEDs as they get rotated around the circle. There's a micro Arduino which is mounted on the circuit board that controls the LEDs, and it updates the LED values. These LEDs are a NeoPixel Adafruit LED strip, and they take a single continuous stream of data from the micro Arduino, which then gets decoded and transformed into the LED state values. As you can see here, when it's rapidly rotated, this produces cool looking patterns, although it doesn't come up quite as well in video as it would in real life.
So here's how it works. Here we have the self-contained circuit that powers the LEDs. The micro Arduino, through a single data stream, powers the LEDs. We created our own custom script that changes the LEDs, which allows us to display patterns. The whole circuit is mounted on a custom acrylic base, which is then mounted on a motor. The motor is powered by a separate circuit to work around having spinning wires.
An Arduino powered by the computer sends a digital signal through a MOSFET, which is functioning essentially as a switch, to our motor. By changing the width of this digital signal, we can effectively send a lower or higher average signal to the motor, affecting the speed. In this way, we're able to accurately control the speed of the motor so that we can fine-tune the speed of the motor to the signals that we're sending to the LED. Next, we'll see and hear a demonstration of this motor control.
The original idea for this project was to be able to display GIFs and images on the LED spinner. We were going to do this by transferring a GIF or an image into a set of polar coordinates, which could then be transferred into LED state values. We've written the code to do this, as you can see by the demonstrations going on screen. However, when we came about implementing the project, we realized that the micro Arduino had significantly smaller memory than we were anticipating. This meant that even though we had done the work for calculating the polar bitmaps, we weren't able to display these images on the LEDs, so we had to resort to creating procedurally generated patterns. The night before the project was due, we encountered a severe technical issue. The motor was heating up to the point that it was melting the glue that we had attached the circuit board with. This meant that at one point the circuit board flew loose from the motor and got smashed to bits. This meant that we had to remake the circuit and the base, and also when we were demonstrating the project, we limited the rotational speed of the motor for safety reasons.